So let's take a look at an example of the first scenario. Remember, the first scenario is given a network address and subnet mask. How many subnets can you have and how many hosts per subnet? Here, we've laid out a chart that we can use for our examples. The first two octets of the IP address, there are 4 octets here. First 2 octets we'll write out in decimal. The last 2 octets we'll write in binary, just for simplification purposes. We're going to use a class B address here, so we can write in the class B address here in decimal by where the default is, and then break out the binary portion here. So the first scenario, given a network address, we'll just use a network address of 172.16.0.0 with a 22-bit subnet mask. Notice I use the slash notation. That's a total bit count that we'll use here. So first thing we want to do when we're doing all these scenarios is write out the mask, and then we'll write out the given address, and then we'll make our adjustments and our editing as we go along from there. So that's the way we'll play this little game throughout all of our subnetting examples. So let's write the 22-bit mask. We've got 8 bits here in the first octet, 8 bits in the second octet. So that's 16, 17, 18, 19, 20, 21, 22. And so the rest of these will be zeros. And that's our 22-bit subnet mask. That's actually the number 255.255.252.0. Now we'll write out the address 172.16.0.0. That's our network address right there. So that's the example here for the first scenario. Now, the question is, given this network address, here's our network address, and a subnet mask, here's the subnet mask, how many subnets can we have and how many hosts per subnet? This brings us to the topic of understanding these different sections. You'll recall that the solution that I gave you was based on a rule 2 to the nth minus 2, where n equals the number of bits in the section. Now, what are these sections that we're talking about? First of all, by default, there are 2 sections. There's the network section, the network bits, and then there's the host section by default. With this being a class B address, there's 16 bits by default in the network section, 16 host bits by default. Here, however, we now extended the default mask beyond the default mask, and we've extended an additional 1, 2, 3, 4, 5, 6 bits. And so now there's a new section in addition to the network section and the host section. Now we've created a new section where we've extended and borrowed bits out of the host section, and we've created a new section called the subnet section. So this is our subnet section right here. So our network section, subnet section, and that leaves over the rest of this for hosts. Here in the subnet section, we have 6 bits. Here in the host section, we have a total of 8 plus the 2 here. So we have 10 bits in the host section. So in order to figure out this formula, use the formula for our purposes, we're trying to figure out how many subnets we can have and how many hosts. We use a formula 2 to the nth minus 2, where n is the number of bits in the section. So in the subnet section, if we want to know how many subnets we can have, we use that formula, and we replace the n with a 6. So 2 to the 6th minus 2. 2 to the 6th is going to be 64 minus 2. It gives us 62 subnets that we can have here. And then, as I mentioned, we've got 10 bits for the host bits here, the host section. And so 2 to the 10th minus 2. 2 to the 10th is 1024 minus 2 is 1022. So we have 62 subnets and 1022 hosts per subnet. So that's an example of that first scenario. Given a network address and a subnet mask, how many subnets can we come up with and how many hosts per subnet?